Good morning, my dear students. I am Dr. M.Bala Theja, Faculty of Mechanical Engineering of SVR Engineering College. In the subject Basic Civil and Mechanical Engineering, in that we have discussed about the topic of IC engines in the few earlier classes. Today, I will give some revision about the topic and even though remaining topics I am covering to you. See, here IC engines. Before discussing about this topic, first I will give the information about the engine. What is an engine? Engine nothing but it is a conversion of fuel energy into mechanical energy. Means if you take any engine of the vehicle, in that you are supplying the petrol, that petrol engine is conversion to mechanical energy. So that is the thing I am calling here engine. These engines are mainly classified into two types, that is external combustion engines, internal combustion engines. External combustion engine nothing but the engine combustion is taking place outside of the engine cylinder, that is called external combustion engine. When the combustion is taking place inside of the engine cylinder, that is called internal combustion engines. But we don't have the syllabus of external combustion engines, but we are having the syllabus is internal combustion engines. So now I am covering the complete topic of the IC engines. So internal combustion engines. Okay. Now what are the classifications we have? See here, I told that engine is nothing but it is a conversion of fuel energy into mechanical energy. See here, in the fuel we are having some chemical energy. Based on that chemical energy is conversion to heat energy. That heat energy is conversion to mechanical energy. So ultimately, fuel energy is conversion to chemical energy is conversion to thermal, that is heat energy is conversion into mechanical energy. So this is also the engine definition. Okay, so simply I am saying that fuel engine is conversion to mechanical engine. So based on the combustion, we are having two classification. When the combustion is taking place outside of the engine cylinder, that is external combustion. When the combustion is taking inside of the engine, that is the internal combustion. Means what is the example of this? If you see external combustion engine, the example is steam engines. If you see internal combustion is, what is the example? The two-wheelers, four-wheelers, six-wheelers, whatever you are seeing, everything internal combustion engines. See here, here in this part, we don't have the syllabus of external combustion engine. Okay, we are concentrating about only internal combustion engine. But in the classifications, you have to write this also. Okay, again, this external combustion engine into two types, that is single acting external combustion engine, double acting external combustion engine. Now, based on the engine, we are having, I have said to you, in the engine, we are having the piston. That the piston movement only we are having two types. When the piston is moving in the reciprocating motion, that is the piston type external combustion engine. When the piston is moving rotary type, that is a rotary type of internal combustion engine. Again, the piston type of reciprocating motion of the engine is conversion to two types based on the fuel. When you have to pour into the petrol as an engine, that is the petrol engine. When you have to pour into the diesel into the reciprocating engine, that is the thing of diesel engine. So here, the petrol engine is again classified on the movement of the piston, that is the two-stroke engine and four-stroke engine. So here also the diesel engine is classified into two types, that is the four-stroke engine and two-stroke engine. So here four-stroke engine and two-stroke, same rotary type of the internal combustion engine also we are classified into two types, that is the Wankel engine, gas engine. So here you can observe the main classifications are internal combustion engine is classified into piston type and rotary type. The piston type again classified into petrol engine, diesel engine. The petrol engine classified into two-stroke, four-stroke, and diesel engine classified into four-stroke and two-stroke. That is you have to remember. So this is the classification of the engine. So now what are the engine parts? So if you see this figure, easily you have to understand. So this is the engine. It is look like it is a classification view of the engine. So here you can observe this is the cylinder. This is the cylinder. This is the piston. This is the connecting rod. This is connecting, and this is crankcase. The piston we are having small end. In the piston we are having piston pin. This piston pin is connected to the connecting rod. The connecting rod we are having the shape is, it is having the small end and large end. The small end is connected to the piston pin and large end is connected to the crank, that is the crank pin. So this is inlet valve, outlet valve. If suppose we are using the petrol engine, that is the spark plug we are using. If suppose we are using the diesel engine, fuel injector we are using. I have said earlier. So this is rocker arm, this is half spring. So this is camshaft. Okay, this is inlet manifold. Okay, this is the combustion chamber. This is piston, piston rings, piston liners. So this is the thing completely. This is the thing, a cooling water jacket, cooling jacket or air fins jacket we have. This is the crankcase. These are the complete parts of the engine. So this is inlet valve and outlet valve. You have to remember inlet valve, outlet valve. So this is the complete engine construction details. If suppose generally what I have said that when the engine is petrol engine, when in the engine we are having only two important difference. Here we are having the spark plug. If suppose that is diesel engine, we are using the fuel injector. If suppose in the petrol engine, generally we are getting in the inside of the engine air and fuel mixture. In the diesel engine, we are getting only air. That is the main difference to you. Okay, you can remember this construction details. Now we have discussed about the terminology of the IC engine. So this is the main terminology. Again, I will tell the concern details. So this is the cylinder. Okay, this is the inlet manifold, exhaust manifold, nothing but it is the way of mixture entered into the cylinder. Okay, this is inlet valve, this is outlet valve, this is the cylinder head. So this is the piston. Okay, piston pin, piston liner, piston ring. Okay, and so this is the complete concern details here also. Free body diagram of the engine. You can observe here what are the terminology we have. So we are having mainly four terminology, that is top dead center, bottom dead center, stroke, bore, clearance value. The piston is moving from here. This is the piston position in the cylinder. The piston moving from here to here. When the piston is moving from here to here, particular this portion, the piston doesn't move upward because this is the marginal movement of the piston inside of the engine cylinder. This marginal movement of the engine cylinder at the top portion of the cylinder, that is called top dead center. Again, it returns to here. It returns to again here to down. That means bottom. But here it is the margin portion of the bottom of the piston. Here doesn't to come to again down because this is the margin portion of the movement of the piston of the bottom side. This is the margin portion of the piston movement of the top side. Beyond this position, that doesn't move to the piston. Beyond this portion, the piston doesn't move to bottom side. So this margin portion of the piston movement at the topmost portion called top dead center, at bottommost portion I am calling here bottom dead center. The cylinder diameter we are calling here bore. The piston travels from bottom dead center to top dead center, that is called stroke. So here the piston movement from the BDC to TDC first stroke. Again the piston movement from TDC to BDC second stroke. When the piston movement to BDC to the third stroke. When the piston movement from the TDC to BDC fourth stroke. So here based on the strokes we are classified into two types, that is a 4-stroke engine and 2-stroke engine. Okay, you can remember that important point. So here one important point I am telling that. So when the piston movement at top dead center, at the same time this is the cylinder head, in between we are having some gap. This gap of the value I am calling here clearance value. This is the clearance value. And from TDC to BDC, we are having some more some space of the volume of the engine cylinder from TDC to BDC of the cylinder. That is the thing I am calling here. I am calling here swept value. So this is the clearance value. From TDC to BDC of the value I am calling here swept value. So clearance value, swept value, when both we have to add, that is total value of the engine cylinder. That is clearance value plus swept value. That is you can remember. Okay, so that is the clearance value, set value. So what it is, you see, the piston move towards to the top at extreme position, that is called top dead center. When the piston move bottom at extreme position, that is called bottom dead center. Beyond that, the piston doesn't move. Beyond that, the piston doesn't move. What is bore? The diameter of this internal cylinder I'm calling here bore. The stroke nothing but the distance traveled by the piston from BDC to DDC or DDC to BDC called stroke. The space available above the piston cylinder at TDC portion of the engine, that is called clearance value. The piston from at TDC portion to the piston at BDC portion is moving, that is called some stroke. This value I am calling here stroke volume or swept volume. Stroke volume or swept volume. The total volume nothing but clearance volume plus stroke volume. These are the terminology of the IC engine. So this is inlet valve, exhaust valve, inlet manifold and outlet manifold. That is, you can remember. These are the important points. Now four-stroke petrol engine. Today now I have discussed earlier these important topics to you, but even though I am giving some explanation again, you can remember that important points. Okay, so four-stroke petrol engine, it is another name we are calling here. Petrol engine we are having another name is SI engine. What is SI engine? Spark ignition engine. Spark ignition engine. So petrol engine we are having a spark plug, so that's why we are calling a spark ignition engine. The petrol engine has invented by the Otto, so that's why in the represent of his name also we are calling here Otto cycle engine. Otto cycle engine. So here petrol engine or spark ignition engine or Otto cycle engine. So three important names we have for the petrol engine. Okay. So based on the stroke, we are having two type of petrol engines. That is the based on the stroke, two type of petrol engines we have. That is two-stroke petrol engine, four-stroke petrol engine. Now we are discussing about the four-stroke petrol engine. So this is the complete details to you. Okay, you can observe what is the concept here. So this is the constant details. This is the constant details of the petrol engine. So piston inlet valve, outlet valve, spark plug. So what is the main difference of the petrol engine and diesel engine? In the petrol engine we are having the spark plug, that is the petrol engine. In the diesel engine, instead of spark plug we are having fuel injector. That is the first difference. Second is difference, in the petrol engine, through inlet valve, air and fuel mixture is entered. In the diesel engine, only air is entered. That is the second difference. In the third difference, the petrol engine we are having outside of the engine cylinder, we are having carburetor, but carburetor is there, but diesel engine we are having the fuel injection pump. That is the three differences we have. Okay, so these three important differences you can remember. Now petrol engine, so that's why we are having a spark plug. Based on that only we have identified this is a petrol engine. So here inlet valve, this is outlet valve. Okay, piston. So this is the connecting rod. This is crankcase. This is the cylinder, and this is the cylinder head. This is a spark plug. Same criteria here. So you can observe the important points now. The piston is at TDC position is moving from TDC to BDC. That is TDC to BDC. That is the first stroke. When the piston moves from TDC to BDC, the inlet valve gets open. When the inlet valve gets opened, the air and fuel mixture is entered. So this process has happened when the piston moves from TDC to BDC. So that is the thing I am calling here intake or suction process. Okay. When the piston moves TDC to BDC, the connecting rod also reciprocating. The connecting rod reciprocating motion converted into crank rotary motion. So here reciprocating motion conversion into rotary motion. This rotary motion is half circle rotary motion. That is 180 degrees. It is 180 degrees. It is rotating taking place. Okay, 180 degrees. It is rotating taking place. Okay, that is half circle revolution, half revolution. Okay, next, when the piston moves from here TDC to BDC, again the piston moves from BDC to TDC. Already we are having the air and fuel mixture. The both walls gets closed. That air and fuel mixture gets compressor taking place. This is the process I am calling here. This is the process I am calling here compression process. Here also when the piston moves from BDC to TDC, the connecting rod reciprocating, the crank will be rotating taking place. Here half circle revolution taking place. So here the movement of the crank is here half, total revolution of the crank is one revolution. So when the crank is rotating, crankshaft also rotating. That is, you can remember. So at the same time, you can observe here when the piston is the TDC portion of the piston, already we are having the compressed air fuel mixture, already both was gets closed. At the situation, we are getting a spark from the spark plug. When the spark from the spark plug, we are getting more energy, we are getting the high thermal energy. That thermal energy is pushes to the piston effectively from TDC portion to BDC portion. So that's a very rapidly the piston to come. The continued rapidly reciprocating, fastly reciprocating, and crank also fastly rotating taking place. When the crank is also fastly rotating taking place, the crankshaft is also fastly moving taking place. So here we are getting some energy. So we are getting the fast energy we are getting. So that's why we are calling here power energy or power stroke. So here we are calling here power stroke process or combustion process. So here power stroke process we are calling this. After getting that, the piston moves from BDC to DDC. After getting that piston moving from the BDC to TDC, already combustion taking place. That exhaust gases gets moved from the outlet valve. Here the outlet valve gets open, inlet valve gets closed. From here the exhaust gases move away from the exhaust valve to the atmosphere by the silencer. So here, when the piston moves from PDC to TDC, you can observe one important thing is the inlet valve gets closed, outlet valve gets beyond that. Here, the exhaust gases will move from outside. So you can observe the important points I am telling that again the piston moving from BDC to TDC. All exhaust gases released from the cylinder. What will be happen? Again piston at TDC portion, that is TDC, again it moves again downward and inlet valve gets opened. Air and fuel mixture entered. Outlet valve gets closed. Okay, so this is the suction process again. The piston move again BDC to TDC. Compression taking place. Both valves gets closed. This is a compression process. Again the piston we are getting spark plug spark ignition here. So the piston moves rapidly, connecting rapidly, crank rapidly moving, and crankshaft rapidly moving. So here we are getting some combustion we are getting here. That is the power we are generating. So power stroke process we are calling. Again piston move from TDC to BDC to TDC. All exhaust gas released from the outlet valve. Okay, from the outlet valve, this is the inlet valve gets closed. So this outlet valve gets closed again. So this is the thing repeatedly we are getting here. So here you can observe here in the suction process, in the inlet valve gets open, in the exhaust process, exhaust valve gets open. So remaining all type of valves gets closed. That is you can remember. So this is the suction process, compression process, a power stroke process, exhaust process. Okay, that is you can remember. This is a half revolution of the crankshaft. This is a half revolution crankshaft. So one revolution, again half revolution, again half revolution. How many revolutions are generating for completing 4 process? 2 revolutions of the crankshaft. So in the 4-stroke petrol engine, we have completed the 4 working process, that is suction, compression, expansion or power or exhaust. 4 working processes are completed. 4 working processes are completed within 4 strokes and 2 revolution of the crankshaft. That is you can remember. Okay. So 180, 180, 360, 180, 180 degrees, 360. Totally 2 revolution, to complete revolution of the crankshaft. So this is the complete information of the 4-stroke petrol engine. So you can see the video, then easily you have to understand. So this is the video you can.
It is called a 4-stroke because 4 up and down motions are needed to complete the cycle. In the first stroke, the piston travels downward as the intake valve opens.
So piston moves from here, TDC to BDC. TDC to BDC, the inlet valve gets open again. Again, air fuel mixture entered. See, again I will tell the first. So this is the first row. You can observe. When the piston moves from TDC to BDC, inlet valve gets open, air and fuel mixture has entered. In the second stroke, the air and fuel mixture gets compression taking place. Second stroke, this is the compression process. Next, third process, combustion, spark generating here. Again, piston moves rapidly here, combustion process. Okay. Again, after completion combustion, again piston moves from the BDC to TDC. The exhaust gases moves from exhaust valve. This valve gets closed. right. Again inlet valve open, air and fuel mixture enter. Again compression, combustion and exhaust process. So here this is a process. See, you can observe this video, you can easily understand how much force is generating. So four working process here you can observe here. This connecting the reciprocating motion converted into rotary motion. That is you can observe. You can observe. See, so this much rapidly the piston movement inside of the vehicles. That is you can observe. You can observe. This is the point. Okay, I think everybody understand. Now see, now we'll discuss about a four-stroke diesel engine. So this is a four-stroke diesel engine. So here you can observe here, this is the diesel engine, four-stroke diesel engine. Diesel engine we are calling here compression ignition engine because we are having the fuel injector. So that's why based on fuel injection we are compression taking place of the air, compressed air. So that's why we are calling here diesel engine again classified into again we are calling it again we are calling as a compression ignition engine or diesel cycle engine. So diesel engine or compression ignition engine CI engine or and diesel cycle engines. So these three names we are calling of the diesel engines. Here also diesel engine we are calling four stroke and two stroke we are classified into. In that four stroke cycle we have discussing now. Okay. Here you observe that diesel engine another name is compression ignition engine, that is CI engine. Another name we are having that another diesel cycle engine, that is you can remember. Same criteria, the piston moves from here also. Main difference of the four-stroke diesel and petrol engine is when the petrol engine we are using the spark plug here, in the diesel engine we are using here fuel injector. That is the first difference. Second difference, in the petrol engine, through inlet valve, air and fuel mixture is entered. But diesel engine, only air is entered. That is the second difference. And third difference, in the petrol engine, we are having outside of the engine cylinder air and fuel mixture combined together in the one device, that is carburetor. But in the diesel engine, we are having a fuel injection pump. These are the three important differences we have. Okay, so here these are the fuel injectors. Okay, the piston move from the TDC to BDC. When the piston move from TDC to BDC, here the reciprocating taking place, the crank will be rotating, the crankshaft also rotating. Reciprocating motion conversion to rotary motion. That is the engine mechanism. Okay. When the piston move from TDC to BDC, the inlet valve gets open, outlet valve gets closed. So only air is entered. So this process I am calling here suction process. Again, the piston move from BDC to TDC, both valves get closed, the air will be compression taking place. So here the compression process I am calling. This process I am calling a compression process. After the compression, here we are getting the compressed air. So on the compressed air we are having at that situation, fuel injector produces the fuel to the compressed air. It will be ignition taking place. It will be burning, it will be blasting taking place. So rapidly the piston moves towards to the BDC. Then connecting the reciprocating crank will be rotating. Okay, at that time both valves get closed. So this is the combustion process or power stroke process or expansion process. Okay, after combustion, the piston move from BDC to TDC. Here, after the combustion gas is released from the exhaust valve and inlet valve gets closed. So complete combustion gases will release from the exhaust valve. Again, Mr. moves from BDC to TDC, the exhaust is released from the exhaust valve. Again, the piston at TDC, again the piston move from BDC, again air is entered. Again here compression taking place, again ignition taking place, again here exhaust is released from taking place. So this is the four-stroke diesel engine working. Here also how many revolutions are taking place of this crankshaft? Here half circle revolution, here half circle revolution, here half circle. So every stroke half circle revolution of the and crankshaft. Every stroke half circle revolution. Here half circle. So here one revolution. Here half circle revolution. One more stroke half circle. One more stroke half circle. So how many half circles? Four half circles. That means to complete circuits, that is two revolutions are taking place. Okay, two revolutions are taking place. So that is the four-stroke diesel engine. So four-stroke diesel engine nothing but here we are getting the by using the diesel, by using the air, by using the stroke, by using the by using the remaining things, we have to get the power energy. So that is the I'm calling here four-stroke diesel engine. You can see this video, you can easily understand. You can observe. Piston move from TDC to VDC. Vacuum has created. Vacuum has created. So the air is entering, taking place. Inlet valve gets open. Air is entering, taking place. This is a fuel injector. Outer valve gets closed. So this process I am calling here suction process. We are calling here suction process. Again moves from BDC to piston. Again moves from BDC to TDC. Again piston moving from BDC to TDC. Here the air will be compression taking place. Air is being compression taking place. So both valve gets closed. So air will be compression taking place. So air is being compressed. Air is compression taking place. Now by the fuel injector we are getting the fuel. By the fuel injector we are getting the fuel. So fuel injection taking place. By the fuel injection taking place. So here air particles, here fuel particles inside of the engine cylinder. What will be happen? See, the combustion is taking place. You can observe. Yeah, combustion taking place. So inside of this combustion taking place. The compressed air, fuel injector, compression taking place. Combustion taking place. Air mixture, fuel mixture by the fuel injector, combustion taking place. So rapidly the piston move, that is the combustion process. Combustion taking place. So after piston, the combustion is after combustion the exhaust gas is relieved from the piston move from BDC to TDC. That is the exhaust gases relieved from the exhaust valve. Exhaust gas relieved from the exhaust valve. See here, complete exhaust gas relieved from here. So you can observe in the TDCB suction process, air is entered, air will be compression taking place, compression process, fuel injector, fuel generated, combustion taking place, exhaust gas relieved from the exhaust process. So this is the complete information of the engines, that is the four-stroke petrol engine, four-stroke diesel engine, complete information. I think you have to get good knowledge about these engines. Okay, try to do hard work and get good result. Thank you so much.